We said we were going to write this expression for average speed with two time values. The time value time is 2, and the time value 2 plus h. So just a teeny tiny fraction of a second after time 2. We said we could use a calculator or a computer to let h get smaller and smaller and smaller, compute this average speed value, and see if we could figure out what is headed toward, see if we could figure out what our average speed is. So this is just one example of a table we could make. Here I have, if I've let h be 1 second, and then 1/10 of a second, and 100th of a second, and if you look at those average speed values, from 80 to 65.6, 64.16, these average speed values seem to be getting closer and closer and closer to 1 average speed. So we could try to guess, we could expect, we could say that probably the speed at that one moment in time, the moment at exactly time equals 2 seconds, is approaching this one value, which is 64 feet per second. And notice we did that without ever letting h become 0. We can't let h become 0 because I will definitely have a 0 in my denominator and I won't be able to evaluate the expression. So we can use this. This is great. 64 is actually the exact correct answer. But here's the problem. We won't always have a computer or a calculator that we can use to plug in smaller and smaller and smaller values of h. And let's face it, nobody wants to plug in 0.00001 for h and compute this expression. It would take a long time. So we're going to use limits. We're actually going to be able to answer this question, simplify this expression that I circled, using algebra. Watch this. So remember that before we start, I've decided that h is going to represent a teeny tiny amount of time. It's a very small difference between time 2 and time just after 2. So watch what happens. I can actually use algebra to simplify this. This is the expression we started with on the last slide, and this is distance at the second time minus distance at the first time. So total distance traveled over that very small time interval. And here in the denominator, this is 2 plus h minus 2 to give h. I could just use algebra to simplify this expression. To take 2 plus h and square it, I would have to write 2 plus h times 2 plus h. It would take 4 multiplications. Sometimes maybe you've learned that to call that FOIL, so I could FOIL that expression. And it turns into 4 plus 4h plus h squared. So I'm expanding in the numerator, and then I can simplify. So notice here, I can distribute this 16. I'll get 64 plus 64h plus 16h squared. Here, 16 times 4 is 64, so my 64s will cancel. And here I have a simplified version, 64h plus 16h squared, all divided by h. I still have the problem, which is that I'm going to have, if I think of h as a 0, I'm still going to have a 0 in the denominator. But watch what happens. Notice I can factor an h out of the numerator, and my h's finally can cancel. And notice that once my h's cancel, I have this new expression, which is approximately equal to 64 plus 16h. But what does h represent? H is a number that's so small, it's practically 0. So at this point, since I don't have a problem with a 0 or an h in the denominator anymore, it's okay to think of h as 0, and notice that that term, 16h, will be equal to 0, and I can cancel it out, and I have my final answer, which is an instantaneous speed of 64 feet per second, which you'll recall is what that table predicted for us when we used the calculator to plug in smaller and smaller values of h.